All right, now that we've removed the dashes and cleaned up our input string, it's time to convert that long string into something Scratch can actually use, a list. First, we set a variable called index to 1. This will help us move through each character in the cleaned up string, one by one. Then we use a repeat block with length of map, because we want to loop through every single character inside our cleaned up map string. Inside the loop, we extract one character at a time using letter index of map. Then we add that letter, which represents a tile value like 0, 1, or 2, into our layout list. Finally, we increase the index by 1, so we move to the next character. So now, we've turned that long string into a list of numbers that Scratch can easily process, perfect for building the level. But wait, why does the first row only have 13 characters? When we first created the map variable, we manually set it to 1 before we started joining it with the cleaned string. That little 1 at the start was added on purpose. It fixes a bug that happens when you don't have a complete row of characters at the top of your layout. Basically, the original input string gives us 14 characters per row. But because of how we join things together, the first row ends up with only 13, unless we add something extra at the start. By adding that 1, we even out the layout so every row aligns properly, and the map renders correctly in the grid. Think of it like a small patch that keeps the rows balanced. Now that we've loaded our cleaned up layout into a list, it's time to convert those numbers into actual tiles on the screen. First, we need to create and set up a few important variables: columns, tile size, and index. Columns is the number of tiles we want per row. In our case, we set it to 14, because each row of numbers contains 14 tiles, except for the first row, which has only 13. Tile size controls how big each tile will be on the screen. In this case, we use a value like 33. Index keeps track of our current position in the list. Once these variables are set, we use a repeat loop to go through every item in our layout list. Inside this loop, we'll be working with values specific to the current tile. So everything we calculate is only for that clone of the wall or brick we're about to place. We start by creating and setting a variable called tile index. This holds the actual value at the current index in the list. It tells us whether the tile should be a solid wall, a brittle brick, or just an empty space. Next, we calculate the tile's position on the grid by creating two more variables, row and col. Row is calculated by taking the ceiling of the index divided by columns. This tells us the vertical line the tile belongs to. We use ceiling to make sure we don't accidentally land on row 0. Scratch indexes start at 1. Col is calculated by taking the index and subtracting the number of tiles that came before the current row. We do that by taking row minus 1 times columns, then subtracting that from the index. That gives us the position of the tile in its current row. Now that we know which row and column the tile belongs to, we can figure out exactly where to place it on the screen. So we create two new variables, x and y, again specific to the clone only. For x, we take col 1, multiply it by the tile size, subtract 400 divided by 2, because our game width is 400, and then add half the tile size. This centers the tile horizontally. For y, we take row 1, multiply by the tile size, subtract 305, which helps us vertically align based on the stage height, and add half the tile size again. This keeps the tile neatly placed in the vertical space. Next, we check the tile index to decide what kind of tile to place. If tile index equals 1, we create a clone of the solid wall sprite. We also set two variables, clone x and clone y, to the calculated x and y positions. These are also specific to that clone. If tile index equals 2, we do the same thing, but for a brittle brick sprite instead. At the bottom of the loop, we increase the index by 1, so we can move to the next item in the layout list on the next repeat. And once all tiles are placed, we broadcast a message to let other parts of the game, like the player or enemy logic, know that the level is ready. Now that we've sent out the broadcast to say the level is ready, we need to finish off the building process. Go to the solid brick sprite first. Inside, add the block. When I start as a clone, then right underneath that, add. Go to X, clone X, Y, clone Y. This tells each wall tile exactly where to place itself on the stage, using the clone X and clone values we calculated earlier. Once you've done that, repeat the same steps inside the brittle brick sprite. That's it. The level has now been fully laid out based on our map string. Hit the green flag and play it to see the results. Every wall in brittle brick should be placed perfectly on the screen, row by row, tile by tile, all from the one string we started with.